Hey, so I got your question. It sounds like you were a little confused about how you count rise and run for different lines in different directions, and for points above or if they're above or under the line. Okay, I think I know what you're asking there. So it's this one is actually not the best example because the slope is one, and so all the numbers are one, so it doesn't really stand out very well to explain. But let me use this one back here to explain that because we have a three and a one and a negative, which kind of helps to have different numbers in the explanation than when everything is one. So first off, you can start counting slope anywhere you want. You'd want to probably pick a spot where it's intersecting at a nice point, like right there, or right there, or right there, where it's crossing at clean numbers rather than at fractional values. And then for rise over run, you can actually get there four different ways. I generally, for me, like to work right to left. I always think of my run as being in the positive direction. So if I travel this way on X, I'm going in the positive direction. If I travel this way on X, I'm going in the negative direction. It still works, and I'll show it in a second. But I prefer to think of the run as positive. And then if my line is increasing, if it goes up, I'm going to have a positive slope. If my line is decreasing, if it goes down from there, I'm going to have a negative slope. So for me, the way that I would think of this is it's going to run three. So one, two, three, because I'm shooting for that next clean point there. My run is three, again, keeping my run positive, and it drops, right? I'm going in the negative direction, so my rise is negative one. There is no reason why I couldn't go rise first and have it drop negative one first and get to that same point going over three, and just counting that second, right? So I can go over three and down one, or I can go down one and over three. Either way, I'm still getting to this point, and my rise is still negative one, and my run is still three. That said, I could also go what for me would be backwards. So if I go backwards on X, now I'm traveling the negative direction. So going from here to this point, my run would be negative three, as I'm going from 0 to negative three. And my rise in that case would be I'm going up, and it would be positive one. But if you look, negative one divided by three versus one divided by negative three, they're the exact same thing. There's still negative one third for that rise. So what that means is for every 3 units that I'm going to the right, I'm going down 1 unit. Likewise, for that last example, I could also go up 1 here and negative 3 that way. So it doesn't matter if I run first, or if I rise first, or if I go left, or if I go right, they all get me this exact same slope. So for consistency, I usually do run to treat that as a positive, up is positive, down from there would be negative. But there's three other ways to do it. For the example that you had actually asked about, let me scroll down to that. For this one, draw a line perpendicular. Okay, so for this one, we're going to go over one and up one. I could also go up one and over one. I could go back one and down one, so that would be negative one over negative one. And any of those versions, the slope is still one, right? Over one, up one is one, up one, over one is one, back, so negative one, down, over negative one is still one. So for me, over one, up one, that would be my choice. And for this, we have the point, and we want perpendicular though this time, not parallel. So if my given slope for this line is 1, then my perpendicular slope, remember, it was 1 over 1. So my perpendicular slope is the reciprocal with the opposite side. So the reciprocal of 1 over 1 is still 1 over 1, right? Because when we flip that, they're the same number. So still 1, and then the opposite side would make it negative 1, which makes sense because these are supposed to intersect at a 90-degree angle. So if this one's going over 1, up 1, this will have to go over 1, down 1 to make that 90. And then to find the line, there's a couple of ways to get there. If we do it analytically, y equals mx plus b. This point is negative 3, and x is negative 3, y is 1. So that's our xy. And we know our slope right here. Oops, that didn't work out very well. We'll do that. So we can plug all that in and solve for b. So let's see what we get. Y is 1, m is -1, and x is -3 plus b. So that would be +3. And then scooting that over, I would get -2 equals b when I subtract the 3 from both sides. So I should get y equals negative, I'm going to write it -1x. You can also write that -x, but just to emphasize it's the -1 from right there. -2 is what my equation should be. So I can also do this graphically, and you can see it's going to come out to -2, so I can probably spot that without doing algebra. If it came out at not a nice value, like the one that you did back here, where it comes out to -5/3, that one's a little harder to read from the graph. But if this one, if we go over 1 and down 1, you can read the y-intercept off the graph right there. So that's how you count slope.